Oh, Mr. Max here already. Can one of you go submit the FRQ Part A for me?
No, not.
Thank you, sir. Okay, number one, rebound sum, no calculator. Okay. Okay, so what are we going to do to show an approximation for R prime? Anybody have any suggestions?
I either thought you would do like the average rate of change, but then just a second ago I was like, could you do linearization?
Well, linearization is used to find values for the function.
Okay, so
There,
no.
so no.
I mean, I did average rate of change.
What exactly did you do?
Um, I did R of 1 minus R of 1/2 over 1 minus 1/2.
And that is perfect. So if we're approximating R prime of 3/4, remember we talked about before, you always want to use the closest points to 3/4. So that would be the 1 and the 1/2. If you used any other points, you would not get full credit there. So you should get about -10, or exactly -10. It does want you to indicate units. So what were your units on yours, Miss Ivy?
Where is that? Gallons per hour. Oh, wait, no. Gallons per hour per hour.
Yep, that's perfectly fine. If you put gallons per hour squared, you would also get credit for that. That'd be fine. Okay, trapezoid rule. Hopefully should not have been too bad. Answer should be 15. Anybody need that shown out or anything?
No.
Mm-mm.
Okay, part C then.
What's the answer?
-9.
Okay, I'm good.
That should be pretty easy. Hopefully that's just a straight up fundamental thermocalculus. Okay, part D. Oh god,
I
summation.
didn't I
Okay.
didn't know how to do this.
So this goes back to when we talked about what goes where for our summation notation. Um, so we know it's going to be a distance of 1, and it's going to start at what looks to be 1/2. And your function will be just 1. Just see, we 1 plus x, I think. Oh wow, that's okay. I don't know how they expect you to get that, to be honest. You get the 1/2 to 3/2. That's fine. Bless you. Bless you again. Oh, because there's an R in front of it. I didn't see that. Okay. Well, that's really early. Okay, so that's not too bad.
Wouldn't it just be R of X?
R of T, or R of X would work fine, yeah.
Okay.
I didn't
So
see the R in front of it. That's why I was getting thrown off at first.
Oh, okay. So
was-
it's just the integral from 1/2 to 3/2 of R of X dx.
That'd work.
Okay. Okay.
I just don't like. I mean, I know we went over it sometime, and it was in the multiple choice. I just this summation thing with like the k's and then like the 1/n.
So
It just
remember that whatever you're multiplying by, so out there, in this case, the 1/n, that is your delta x. And remember, delta x is b minus a over n.
okay.
So that tells us our a and b value in this case has to differ by 1.
Yeah.
And then when I look on the inside, so since it's r of that stuff right there, remember when we do our summation notations, it's usually f is our function. So it's the function of your starting value plus k delta x.
And delta x is 1/n, so it's k/n.
Right. And that's going to be kind of your basic formula there. So it's always going to be where you have your a of, I'm going to call it a1 plus k delta x times delta x.
And the formula is always like the function of
Right.
a1, whatever.
And it'll be up on the board in a second for you.
Okay.
But yeah, that's the general form of it. That's why, like I said, at first without the R there, I was thrown off. And I was like trying to figure out how they were expecting you to get R of T, and then I realized there was an R. Well, I'm still waking up myself, so.
Oh, I got you.
So they just changed it to R instead of F, that's all. So it shouldn't have been, I mean, if you remember that, obviously it's not too bad. And fortunately, if you can write that down and have it for you this year, but I mean, I don't think it's going to appear, to be honest. I don't think they have enough room to fit that in. Which apparently there was information put out last night that I didn't know about, so I'll watch that video and get information to you guys as soon as I can. Alright, any questions on number 1 then? That was a pretty quick one, to be honest. Pretty easy. Okay, number 2. Give us a graph, and they gave us the areas. That's nice of them. Did they really ask us for that when they gave you all the areas? Okay. So number 1 should be, what, 17 minus 11, so 6.
Yeah.
B,
I didn't know how to do B.
given that f of 6 is equal to 7, our expression that involves an integral, use this expression to find the absolute value. So it's FTC.
But what other value do you use?
0 to x. It says using the right expression of f that involves an integral. That means the integral of f prime of x. I'll show you in a second. Don't worry. Okay, so we'll do that part first, and then I'll do the maximum thing. So anytime they say write an expression with an integral in it, that means you're going to do the integral from somewhere to x, or x to somewhere, one or the other. Usually it's somewhere to x. So what they're expecting you to get, what value did they gave us, what, 6? F of 6 was 7 or something like that, right? Yeah, f of 6 was 7. So we're going to do from 6 to x of f prime of x dx is equal to f of x minus f of 6. So what I have on the board should make sense, right?
Gotcha.
And now they just want you to solve for f of x. So that's an equation for f of x that has an integral.
Does it matter that it's lowercase f?
Did they use uppercase F or lowercase f?
It's just not like the question.
Oh, typically if they give it to you in, like, whatever, if they're giving you the function, yes, you want to use that. If not, then no. So you could have used any variable you wanted or any letter or function you wanted. They, however, said for f of x, so you really should follow that. So f of x equals, move that over, integral from 6 to x of f prime of x plus f of 6. And there's your function for f of x involving an integral. Yeah, anytime you see that, write an equation involving an integral, it's always going to be from whatever value they gave you to x, usually. That's a pretty standard way of doing it. Okay. One second, sorry. All right. Okay, and then use this expression to find the absolute minimum value of f and the absolute maximum value of f on the closed interval from 0 to 9. So now that we have our function, I'm assuming you guys should hopefully be able to find a, I forgot my dx on this. And if you wanted to, over here on your f prime part when you're writing the integral, you can technically put any variable you want in there. So a lot of people don't like the whole using x's twice. So like using x on the inside and x up here. If you don't like that, you could write this as these as dt's if you wanted to. That's a personal choice of yours. Especially a lot of students, they tend to get thrown off by the fact that, hey, they're both x's, you can't have that. So if you don't like that they're both x's, you can put them as t's. You can really use any variable you want, including x. X is perfectly fine. But now if we want to max or min, just take the derivative. So f prime of x is equal to, well, hopefully that should be really easy. What's f prime of x equal to? What's happens if I take the derivative to the right-hand side?
F prime of whatever you wrote dt.
But no, so we got to use, at this point we got to use that variable. So f prime of x is equal to f prime of x. Oh my god. That's a miracle.
Yep.
So if you differentiate both sides, you get f prime of x. So at this point, we are now, I don't know why it says use this expression to find anything. You have the graph of f prime above, so it's really dumb, but whatever. So you're just looking for where the graph of f prime goes from a max to a min, or a, et cetera, et cetera.
So you can just look at the graph, really. You don't have to.
Yeah, because you're looking for where f prime goes from positive to negative or negative to positive. Let's see, and we want the absolute, so you have to be careful to check all critical points and the endpoints. So we will actually need to use that expression since we're looking for absolute, not relative. My bad. So we know critical points are 3, 6, 8, and 9, it looks like. But 9 is also an endpoint, so it doesn't matter. So you'll have to check and do the evaluations. So this is actually irrelevant. We don't need that. What we have to end up doing, since we know critical values are x equals, was it 3, 6, and 8, I think I said. So, yeah. 3, 6, and 8, and endpoints are 0 and 9. So you need to do f of 0, f of 3, f of 6, f of 8, and f of 9. So in other words, they're asking you, since they gave you the areas, this is not really that difficult of a calculation. What is the integral from 6 to 0? So looking at your graph now, because you will use the graph values, what is the integral of f prime of x from 6 to 0?
Is it -2?
Yes. Very good. So negative 2, and then plus f of 6. What was f of 6 again? Was it like 7? Yeah.
7.
The EP.
Endpoints. So you get negative 2 plus 7, which is 5. And then what is the integral from 6 to 3?
Positive 10?
Yes. So you get 10 plus 7, 17. What's the integral from 6 to 6?
0?
6 to 8.
5?
And then 6 to 9.
4?
So everybody see how Miss Ivy was getting those answers correct? Yes.
Yes.
All right. And then once you have that, you just tell me what the max and tell me what the min is. Now, just to be on the safe side, you might want to show out at least one of those with the integral in there, as far as that calculation, like maybe the first one or so at least. Definitely show at least the calculations of the adding the two things together, just to be on the safe side to make sure they're going to give you credit for all of your work. But they really should be fine with you just saying like what I have there. But just to be on the safe side, you want to show at least one of those out with plugging into the function, just to be safe. So like maybe on the first one, I would have done the integral from 6 to 0 plus f of 6 equals negative 2 plus 7 equals 5. And then the rest of them you should be just fine doing. I don't, I don't think they would take off points if you have what I have up there because you're showing that you're adding the two values and everything like that. So I don't think they would, but I can't guarantee. And then obviously tell them what the min and tell them what the max is. And hold on, let's see what exactly does the question say. Find the absolute maximum value of f. So you only need the maximum value. You don't need where it is. So make sure you always pay attention to if they're asking for where does the maximum value occur, what is the maximum value, things like that. So make sure you answer their question. Otherwise, you may run the risk of losing a point or so. Any questions on that one? Okay. Moving on to C. Oh, I just went the antiderivative of G. That's okay. Nobody should have messed that one up. 1/3 x squared, or 1/3 x cubed minus x plus c.
Yep.
Yep.
Part D, find the value of the integral of x f prime of g of x.
I need help on this one.
It's going to be a u sub, but u is g of x. It'll probably be a lot easier for you to recognize that if you replace g of x with x squared minus 1 in the actual problem. And then you would have had x f prime of x squared minus 1, and you would have realized that x dx is the derivative in part of the x squared minus 1. Does that make sense? So there you go, x f prime of x squared minus 1. So you end up making u x squared minus 1, so then du is 2x dx, move the 2 over, so 1/2 du is x dx. So when you got to make your subs in, you get the integral of f prime of u du with a 1/2 sitting out front. So it's just 1/2 f of u, and then plus c, bring back your x squared plus or minus 1 into it. And they probably want you to use the function you found above. So that's going to be 1/2 of the integral from 0 to, 6 x squared minus 1 of f prime of t dt plus f of 6 and plus c. I'm assuming that's roughly along the lines of what they want. Let me check to make sure. Oh, we have actual values. I didn't realize we had actual values.
We did too.
So we'll still probably need that, but so no plus c, get rid of u. Evaluated from 2 to 3. Evaluated from 2 to 3. So we'll have to plug in 3 and 2 here. So we get 3. If I plug 3 in, I get 9 minus 1, which is 8. And then minus the integral from, if I plug in 2, I get what, 5? Nope, 3. So from 6 to 3, f prime of t dt plus f of 6. Shrink. So the f of 6's end up canceling. They're irrelevant. We've already done 6 to 8. What was that value? Is that like 5 or something?
Yeah, 4.
6 to 8 was 4. Okay. What was 6 to 3?
Positive 10.
So you get negative 6 and negative 3 is what that would be if we did everything right. Negative 3 halves. Don't forget that. Oops. It's showing that 6 to 8 was 5. Yeah, 6 to 8 is 5, sweetie. Gotta be careful. 6 to 9 was 4. So 5. So yeah, negative 5. So I need new markers. Gotta get to the store today. Oop. I have a mistake. Please don't do it. I do. I can't have both of these lines. One of them is wrong. So don't do, with the f of u part, don't use the same bounds. Be careful with that. You have to use those as x's only. So that would have been up. Sorry about that. I had to sneeze. Don't use x numbers with u's. I made that mistake. That would have been probably, I would have lost a point for that or not gained a point somewhere or something because that would have been technically incorrect.
What happened to the X?
What x?
It's like X, like in the very first line.
It got absorbed by the du.
Oh, it's X.
X dx. Mm-hmm.
Yeah, okay. I didn't see that small X. Never mind.
That makes sense to everybody, hopefully. Okay.
Good. Makes sense.
There we go. Alright, moving on to part B, which looks to be improper for you guys. Okay. Alright, so question A. Approximate while using a left Riemann sum with the intervals. Okay, they gave them to you. That should be real easy for you. 53 fourths. questions on that one?
I guess I didn't. You said 53/4.
That's what they got, yeah. 12 plus 1 plus 1/4.
12. I got 12 plus 3/4 plus 3/10.
Okay, so for the second one, you should have done 8 minus 4 times f of 4, because we're doing a left Riemann sum, yeah.
I guess I kept doing 3 because in my head I was like, they're really 3 spaces apart, you know?
Ivy. No, they're not 3 spaces apart, they're 4.
Okay. And then so
12 minus 8 times f of 8 for the third one.
and f of 8
F of
would
8
be
would be 4 over
10.
64, which is
Oh,
4 over 64 ends up being, what, 1 over 16?
Yeah.
okay.
And then 1 over
Got it.
16 times 4.
Yeah, that was just me.
That's fine, it happens. Just gotta be careful. But remember, you should literally leave it out. Like, you could write 4 minus 1 times f of 1, but then you have to replace f of 1. So you could literally leave it as 4 minus 1 times 4 over 1, plus 8 minus 4 times 4 over 4 squared, plus 12 minus 8 over 4 over 8 squared. You can leave it like that. Do not forget that. And please, please do that so that you don't make any minor calculation mistakes. Now, obviously, you'll have a calculator on every part this year, but still leave it written out. Do not make those mistakes. It also saves you some time, so you have time to get to the full question. Okay, so B, find the value of 1 to 12 f of x dx. Okay, that's super straightforward. Answer being 11/3. Anybody have any issue with that one? I don't think you would. Okay. What was that, Megan? Anna?
I said you can just plug that in your calculator.
This is a non-calculator question. You have to show the work that leads to your answer. You can check it with the calculator, yes, but... Alright, C. This is where we get our improper integral, finally. Find the value of that or explain why it doesn't exist. You should be able to get an answer, and the answer is 4. A couple things to point out. Make sure you are using your limit notation correctly. So you need to rewrite this as the limit as most people, we would mostly use b here. So the limit is b goes to infinity of the integral from 1 to b of 4 over x squared dx. And remember, you keep that limit notation until you actually evaluate the limit. This one's not tricky in any way, though, so you guys should be just fine. But definitely make sure you're looking at doing that properly. Okay, then part D, find the value of f of x times ln of x dx.
I did not get this one.
I'm going to say it's probably, before I even look at the answer key, it's not a u sub because that doesn't work. It's probably integration by parts. And yep, integration by parts. Because there's no way you're going to be able to, if you try to do the ln x being your u, you get only 1 over x dx, but you have 1 over x squared dx. So there's no way you're going to get it, so it has to be u, uv integration. So the question is, which one do you make your u and which one do you make your dv? That's always the hardest part to pick. Any suggestions on which one being which? Nobody has any suggestions for which one for U or V? Or U or DV?
I don't have my notebook out, but I think I did. U was ln x and f of x was dv.
So why would you make U ln x? That's the question.
Because I don't know the derivative, the integral of it.
You don't know the antiderivative of ln x off the top of your head?
I forgot it? What is it?
It's x ln x plus x.
Oh yeah, we did do that. Well, that just makes it
I was
harder.
I was joking. To do the antiderivative of ln of x, you have to do integration by parts. So clearly you would not want to make ln x your dv.
But I do remember that actually though.
But yeah, the antiderivative of ln x is x ln x plus x. Should you have that memorized? No.
I didn't know that.
You should not have that memorized. We've just done it enough that for whatever reason, it's stuck in my head. But the only way to do the antiderivative of ln of x is to do it by anti-differentiation by parts, with ln x being your u and 1 being your dv. It's not something I would expect. It was 4 over x squared, right?
Yes, I think.
Okay. So yes, definitely do not make your ln of x. Always make your thing that you can take the antiderivative of easier, your dv. That's always the hint there. If you can take the antiderivative of both, you kind of got to do a pick and choose game. But in this case, you definitely do not want to be taking the antiderivative of ln of x. That would make no sense. So then at that point, we get negative 4 over x ln x minus the integral of e du, negative 4 over x squared dx. Which at that point, that's a relatively easy antiderivative to take. If I did that right. Yeah, I did that right. Okay. So then you just take the antiderivative of that, so you get negative 4 over x minus the integral here would be, what? Negative, so 3 negatives makes a negative, 4 over x. And then we're going to evaluate that from 0 to 12. If I did all that right. Negative 4 ln x minus 4 over x. Yeah, I did that right. Okay. Oh, it's 1 to 12, not 0. I should have realized that 0 didn't make any sense. 1. And 1. Then just plug your 12 and your 1 in. So you get negative 4 ln 12 over 12 minus 4 over 12 minus negative 4 ln 1 over 1 minus 4 over 1. The ln 1 is 0 in case you don't remember that. You could leave it just like that. That's perfectly fine though. That's how I would do it. Just honestly, no sense in trying to algebraically manipulate that at all. They do, and they get a thing, but I would just leave it just like that. You can even leave the ln 1 there, even though it goes to 0. If you leave it, it's not wrong. Hello? Okay, yeah. Thought my mic cut out for a second, sorry. Any questions on that one?
No. I did it all right, but I messed up my signs somehow.
Which one?
I think I had. Oh wait, no, never mind. I factored out a negative 1. That was why.
Oh, okay.
How did like AB do this?
AB doesn't do this one. They don't do
Oh,
integration by
really?
parts. Yeah,
Okay.
their question will be different.
I didn't know.
Yeah, they take out all the BC stuff and change it. So they'll probably have question A is fine, question B is just fine. They'll have a different C and D probably, is what it'll be. That'll do some sort of, their integration will probably be like a U sub integration versus a UDV integration. What they like to do for some ungodly reason, which I never understood, I don't understand why, is they'll have some of the same questions, but then they will change the numbers, even though it's like no reason to change the numbers. I'm like, why did you create two different questions? Because I'll be doing the problem like it was you guys' problem, and they'll be like, that's the wrong numbers. I'm like, what do you mean? And like, 'cause I'm not paying attention because I was like, oh, I've done this already. It's this, it's this, it's this. And they'll be like, that's the wrong number. I'm like, what do you? I'm like, oh, they changed this number for no ungodly reason. Got it. So yeah.
Nice.
So like for their part, see, they may just have like a limit problem of some sort where you do a limit because you guys had to do a limit there. I don't know. We'll see when I do it later, but it's a slightly different problem. Okay. All right. Any questions?
No.
Well, then you guys get tomorrow off as well. So don't have to wake up
No
early.
way.
Did you say no way?
No way.
Where
I love law.
where have you been at since I told you guys it's basically we're gonna have 3-day weeks. As long as we get through everything and we have 3-day weeks.
That is fabulous. Wow.
Anna's about to cry tears of joy.
So is it you don't like my voice? Is that what it is, Anna? You just hate my voice, can't stand it, make your ears bleed.
Yep.
You know, that could be a contributing factor.
I see how it is. Uh-huh.
I'm just kidding. I'm just kidding.
That's fine. No class for the rest of the year. Good luck on your AP exam.
Sweet.
Shut up, Tanner.
Literally, I don't want to take this AP exam. Like, I don't think you understand.
I think I'm genuinely gonna fail. I want you to know that now.
I think everybody here will be genuinely fine because you're going to show the calculus that you know, and you're going to be just fine because you guys are smart. And worst case scenario, which is not going to happen, but you fail. What does that change?
Yeah, literally, I could fail and I'd be okay with it. Like, I literally don't care.
I mean, I don't want you to be okay with failing. However, again, worst case scenario, which will not happen, I repeat, will not happen, you fail this